In this session, we are going to discuss another important issue, pattern mining and society. Especially, we'll be focusing on the privacy issue in data mining. We know we are living in a data-rich or big data society. This, of course, creates great opportunity for successful data mining. But on the other hand, people do have concerns whether pattern mining may violate people's privacy or security. Okay. Actually, data mining may naturally have potential adverse side effect is compromise the privacy. Privacy and accuracy are typically contradictory in nature. That means if you want your pattern mining very accurate, in many cases the privacy may be compromised. But if you want to protect your privacy in a very tight manner, then the accuracy of the pattern mining may suffer. Okay. So the problem is we need a new technology to do privacy-preserving data mining. We ensure the data mining will achieve good results, but in the meantime, we're going to protect people's privacy. There are lots of research working on this issue. We call privacy-preserving data mining. Okay. The study generally focused on three categories on privacy. Okay. One we call input privacy, or you can think about data privacy. Essentially, how do we hide data? We can distort data, we can hide data to prevent data miners from reliably extracting confidential or private information. Another category of privacy is output privacy, or we say knowledge privacy, knowledge hiding problem. That means whether even the input data may be okay, but once we find patterns, certain pattern or knowledge could be sensitive. You may not want to disclose it. So how we can guarantee we do the mining, we can ensure the output privacy. Okay. This is another interesting issue. The third issue people studied called owner privacy. That means the people, any party may hold certain data. For example, different hospitals may hold different kinds of patient information. You may want to study, for example, AIDS or heart problems or lung cancer or those problems. Okay. But you may not want to see where the data come from. That means you actually want to hide the data owners or the hospitals, hide the source of the data. Then you can do more study. This we call owner privacy problem. So in this short session, we are going to focus on how to ensure input privacy, or you can say data privacy problem. Okay. Of course, one simple approach could be you trust service provider. They are going to anonymize their data, and especially the use of private information. They are going to anonymize them, and they are going to ship those anonymized data to data miners. This model we call business-to-business environment, or service provider to data miner environment. That means you have to trust both parties. But the problem is, do you really trust them? And most people may say no. Okay, so that's the one. Of course, this could be quite popular in the regular practice, but you want more. Okay, so the second approach we call data anonymization or perturbation. That means we ensure data privacy at owner side, at data source side. Usually this anonymization, even you may not trust the service providers, you actually will try to ask the third-party vendor to anonymize the data before they can release to anybody. Okay, this one we call business to customer environment. And the typical method developed like a data perturbation, data transformation, data hiding. That means we may want to hide some sensitive value or sensitive attributes. Okay. Let's look at this table. This is suppose we have a hospital. It contains certain problem of the data is patient ID. You get zip code, you get age, you get say disease. Okay. people may not be comfortable on this kind of data because even you anonymize patient name, but you may got to some people may know the patient's age and zip code. They can easily say, oh, this person got a heart problem. Okay. So then the method could be, what about we make it a little more generalized. We hide the last two digits of zip code. Then we hide the last digit of their age. That means you only know is at a 018 something zip code, and in the 40s, got a heart problem. But then you see for the same, zip code and same 40s, there are lots of other disease. So you will have no way to tell this person whether they got a heart problem, cancer, flu, or anything else. Okay. So in that sense, you may feel more comfortable. If you got 3 records, you may still not feel very comfortable. But what about you get 100? You probably say that's okay. Okay. So this actually we call it K-anonymity problem. That means every equivalent class, that means they have the same zip code and age, they at least have case records. And if this K is reasonably large, you feel probably much more comfortable because within this 100 different disease, nobody can guess what you have. Okay. So, but this may not still be sufficient. For example, what about all these age, the zip code, and in the 30s, everybody got diabetes. Then, then you release it, then easily they can see you do get diabetes. Okay. So that means this record, even this K, is not sufficient. You want to ensure this disease, this sensitive attribute, got at least L distinct values. So we call this is L diversity. But even this L diversity, what about the majority of people got diabetes? You still feel not comfortable. Okay. So there are other studies, further studies, for example, T-closeness, differential privacy. So there are lots of research ongoing to see how to ensure people have no way to guess what you have. Okay. Of course, even for L diversity, if the majority, suppose, is HIV negative, probably this majority you will not really have concern because, HIV negative is not a concern. Okay. So that's the thing you probably can see. That there are many issues to study to ensure privacy in this way. Okay. So I will not get into detail, but there are many good research papers. I list at the end some typical papers. You may like to go deeper by reading them. Now I'm going to discuss a little on data perturbation methods for privacy preserving pattern mining. Okay. The data perturbation, usually people use a statistic approach. That means using some randomization algorithms to distort the data. One way you can do is we call independent attribute perturbation. That means you take each attribute, you perturb their values independent of the other attributes. Okay? You don't have to think about the other attribute existing. Like you perturb the zip code or you perturb the age, so it doesn't matter. But for pattern mining, you want to find the correlations. So sometimes you may like to see dependent attribute perturbation because the pure independent you do perturb, these correlation may be lost. That means if you want to take care of the correlation across attributes, you may concern to develop some dependent attribute perturbation method. Okay. And for this data perturbation, there are some interesting studies. One method called mask. That method was, if you think your shopping transaction contains lots of items, okay, usually one transaction may only, that means one shopping basket may only contain 10 or 15 items. But if you go to Walmart, there are so many items, you can think all these items is a very long vector. Okay. In your own shopping basket, only a small number of these factors turns to 1. Okay. But you want to hide what exactly you are buying. Okay. So in that sense, you may turn the other items from 0 to 1 and some of your one item turn to 1 to 0 with certain probability. Okay. With this, if you carefully tuning this P, you may achieve both good average privacy because you insert a lot of randomly picked up item. They will not figure out what you bought, but you still get a good accuracy. The reason is, in general, those patterns, once you randomize lots of different items, with this randomization, unlikely they will become frequent. Okay, so the pattern may still, your real frequent pattern may show up. Okay, but this method actually may turn, because the majority things are zeros, you may turn many things into 1 with certain probability, so that may increase your number of items in each transaction quite a lot, make your database really big. Okay. Even you can find patterns, it could be substantially slow. There are studies on how to ensure both efficiency and accuracy. Okay. Another method studied called cut and paste operator. This essentially is using uniform randomization. The method is you get a real transaction, you don't increase items in this real transaction, but you take the existing item, you have a probability to randomly replace some existing item with a new item, okay, not present in your original transaction. So as long as you do not make your probability too big to replace them, you still get a good patterns show up. Okay. So, but sometimes if you replace too much, you get a quite worse case, on the accuracy, or you replace too little, you may get a worst case privacy. So there are methods studied how to balance both, how to select items in an organized way, okay, to improve the worst case privacy, but still keep good accuracy. Actually, the experiments show if you want to mine, short transactions, short patterns, short item sets, okay. So these cut and paste randomized database, you mine it, you may correctly identify 80 to 90% short patterns, like length less or equal to 3. Okay. But if you want to mine long patterns, because of such perturbation, a lot of a long pattern may be destroyed. Okay. So how to effectively mine such long patterns, still remain good privacy, is an open problem. Okay. So privacy-preserving data mining is still a very active research field. There are lots of research papers published. For example, Rakesh Agrawal, they got the first paper published in year 2000 in Sigmund, and there are books. And I also intentionally put a privacy, differential privacy, like T-closeness, error diversity, those papers here, because I did not really lecture this to any detail. Okay. So interested reader, you may like to read those if you're interested in further push forward the frontier of privacy preserving in data mining. Thank you.